Hello, welcome. This is again another one of those videos that isn't a topic video by itself. Sorry, the camera. Yeah, sorry about that. It's alright. Yeah, to the left. Sorry. Okay, so this video, as you can tell by the title, is distinguishing between the the resolving power. Okay, which in your formula sheet is given as lambda over d. Okay, in other words, the wavelength of a particular light on this telescope. Okay, and over the diameter of that particular telescope, and something called the angle subtended. Okay, which is calculated by S over R. S being the separation. Okay. Of this particular planet you're looking at over the radius, in other words the distance from you to that planet. Okay, so as you can see that both are labelled as an angle. Okay, this one critically is called angle subtended, that's called resolving power. Okay, now the first thing I want to go over before I go into the distinguish between the two is, well, obviously you can see why that's got an angle sign there. Okay, that's what that's meant to be. Probably that's a bit too long, but you get the idea. Okay, they've both got an angle symbol in them. But I've said this is called resolving power, and the reason I've said that is because that's what it says in your formula sheet. If you look on your given formula sheet, okay, it will say just before that it will say resolving power. Okay, so what does it actually mean? Well, in simpler terms, okay, more complicated terms, to actually explain why I've got an angle here, okay, resolving power is the minimum angular separation between two planets, okay. Now, the way I think of this is this one here, okay, the resolving power is when you're talking about a telescope, okay, because obviously we've got the diameter of a telescope there, so we're talking about a telescope. Whereas in the angle subtended, now this one, you're not given in your formula sheet. You have to remember it, okay? So you do get questions on it saying, calculate the angle subtended, and some people try and use that equation, which obviously you can't because the different parts of the equation, okay? So obviously that's to do with the telescope, this is to do with the human eye, or human, if you want to call it that, okay? Some people aren't, some people are animals, disgrace to the human race. That's a good catchy thing. Anyway, so basically, if you were ever to draw a diagram trying to represent this S and R business, okay, the angles subtended, what I do is draw a big planet and little speck, that's you on the planet, okay, and another planet a bit further away. So if you kind of draw it like light rays or diffraction, okay, what we've got here is these lines here, kind of your sight lines, your vision lines. If you imagine a camera, okay, I probably could do this from behind the camera actually. So you can see if I kind of put my hand here, you can see it. If I put it over here, you can't. So if you kind of track that along where you just see the bobble of my hand, okay, I try and put it as furthest away as I can. If you continued that out, okay, we'd end up getting further away. So we'd end up with something like this separation, kind of like a triangle thing, if you will. Okay, so hopefully that explained why I've drawn these lines like I've drawn them. And R is this part of it here, okay, and S is kind of, it's almost like the width of the planet really, but it's what you can see. Now that's very, very big, okay. In reality, this line, if you were stood on the planet, obviously that's not in size of the relation to the planet. I've just blown this bit up, the sight lines, the angle subtended, because what's calculated is the angle here, and you can quite clearly see in contrast to them two, that angle looks very big. But when you actually calculate this in a question, it'll be like 0.0007 radians or whatever it might be. Okay, so this is, as I say, blown up, but in reality it might look something like this. So a very, very small angle. Okay, so that's basically what it is. Now, so hopefully you understand what the S and R business is. Now just to reiterate, as I said, this is to do with the telescope, this is to do with the human eye. But specifically, they're both looking at the minimum angular separation between two planets, okay? This is just done with the telescope and this is done with the human eye, okay? Now obviously you can't do the separation between you and another planet. If you stood on one planet, you can't see the difference between them, but you kind of adapted it for this equation. Okay, it's how much of that, if you look up in the sky, this angle subtended is like, say for example on a night, you look up in the sky, if you see a clear night, you can see the moon. Now that S, okay, that S represents the width of the planet. It's not actually, you can't just assume that's the radius of the planet, because obviously that would be confusing if we put R there. But it's, if you look up in the sky, okay, you've got, if you see the moon in the sky, if you actually look at the top of the moon and then move your eye level down, okay, to the bottom of that moon, from what you can see, that's the width, that's the angle, okay. And you're trying to work out what that angle is from you looking at the top of that planet, okay. So say, hopefully this will explain. So say this circle here is us looking up at the moon, okay. If we look here to here, okay, we're tracking through an angle. Yeah, we're going down through that angle. So I'll try and manipulate the camera to show you what I mean by this. Okay, so let's sorry. Yeah, camera. Okay. So say if we look at, say this is what I'm talking about when I talk about angle subtended. Okay, so the camera's at a particular angle now, whatever angle it is, it doesn't really matter. But this angle here is called the angle subtended. So if I go from here to the top of the planet and move the camera all the way down to the bottom of the planet, okay, that is the angle subtended. That angle there that we're going through, starting there and ending here. Okay, so that's the angle subtended. What I'm talking about is looking from the top of the planet to the bottom of the planet. Okay, or vice versa. That angle we went through there is called the angle subtended. Okay. And that's the difference between those two. In essence, if you're just literally the kind of person who wants to know the least possible, this equation is to do with the human eye, this is to do with the telescope, and in this one we talk about the wavelength and the diameter, whereas in this one we talk about the separation S, which is that angle I talked about, over the distance between you and that planet. Okay? So, a very quick video just highlighting the two differences between these two equations, because I did get a little confused when I first did this topic myself. So hopefully that's helped you, and we'll see you in the next video. Thanks for watching.